Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Praise be to God who have given us blessing so we can gather here in order to our presentation about ISAS with the title Edit Distance on Dynamic Programming. First thing, I will introduce you. We are from Group 4 from 2SJ7. We are, let me introduce to you our member of group. First is Semoga Bermanfaat, second is me, Musa Habibur Rahman, and third is Muhammad Wildan Mokhaladun. We authoring this ISAS or this this project ISAS with the title of this Edit Distance on Dynamic Programming. This journal is our first ISAS in this second semester. Next. First session, our first chapter is about introduction. Why we choose this title for our journal or research. Background. First, in this world of programming, there are many types of algorithms that we can apply in solving problems that we often facing. This can be separated from the many scientists who have been active in this field and in fields related to computer programming. For example, in the case of the algorithm that we have chosen of our ISAS-STEM, dynamic programming, developed by applied mathematical scientists, which is the basis of this method without being separated from the application of mathematics that make it discoverable and developed. This business work, this business actually often face problems that require solution or decision that span several time periods. Dynamic programming can be one of the methods that can be applied or can be the solution for those problematic that appears and facing those businessmen. Because this technique is a multi-stage process optimization, and a decision-making problem that has several stages is broken down into a series of problems or subproblems which are sequential and interrelated. Next session is a definition of dynamic programming. Dynamic programming is a problem-solving method where the solution to a problem is seen as a variety of decisions that from a series of interrelated ones. This method was invented in 1957 by Richard Ernest Bellman, an American mathematician. Dynamic programming is basically an approach or methodology in solving a series of problems using a mathematical approach. The way it works is by counting or dividing the problem into several subproblems. The results of these smaller subproblems are remembered and used for subproblems the same or overlapping. So it can be concluded that dynamic programming reuses the result of previous subproblems calculation. This is can be called a recursive method. Most of these algorithms are used for optimization so that when solving subproblems, dynamic dynamic algorithm will try to check the result of previously solved subproblems. The solutions of the subproblems are combined to achieve the best solution. This algorithmic strategy has some fundamental similarities with other algorithm strategies such as divide and conquer. It can also be said that this programming solves a problem by breaking down the solution into a set of steps or stage, so that the solution can also become a view as a series of interrelated decisions. The limiting problem solving characteristic in dynamic programming are: first, the solution in each stage is determined from the results of the previous stage solution. Second, in order to limit the option that must be considered in finding a solution at a certain stage, optimization requirement and constraints should be used. And the last or the third has a number of possible solution options. Approach or method in solving problems in dynamic programming. There is two approach in this solving problem. First is dynamic programming forward or up down. Suppose x1, x2, and other xn present the variable decision that must be made for each stage 1 to until n. Then the dynamic programming moves from stage 1, continues to stage 2 and 3, and continue until stage n. The sequence of decision variable is x1, x2, until xn. The principle of optimality in the forward dynamic programming forward, the cost at stage k plus 1 is equals the cost generated in stage k plus the cost from stage k to stage k4 plus 1. So k is equals 1 to until n minus 1 or before n. Second approach is dynamic programming or programming dynamic on backward or bottom up. It's same or up down, but the difference is the cost k plus 1 is before the cost of k plus 1 to stage k. That's the difference. The next session is about edit distance.
In slide 7, definition edit distance. Edit distance is the minimum amount of mutation needed to convert a string to another string. The point mutation is to replace, add and remove a character. Next slide. Edit distance from to string s1 to s2 is the minimum number of mutation point needed to change s1 to s2. Point mutation is one of the following activities. Replace characters for the string commuter and computer by changing the letter M in string 1 to the letter P. Then string 1 will be the same as string 2. Add characters. For example, the string short with sport by adding the letter P in string 1. Then string 1 will be equal to string 2. Delete a character. In contrast, by removing the letter P in the string sport, then the string will be a string short. Thank you.
Okay, conclusion. Conclusion that can be drawn from use that edit distance algorithm and dynamic programming is that this algorithm works quite well with less complexity of the method exhaustive, search, and the level of accuracy in the finding solution optimal, which is higher than the greedy algorithm. Suggestion to better understand about edit distance search, it can be done with proof by using algorithm other than dynamic programming. Thank you for attention. Assalamualaikum warahmatullahi wabarakatuh.